Powering the future, exploring different types of renewable energy. With increasing worry over climate change and energy consumption expected to grow by nearly 50% by the year 2050, emphasis is being placed on renewable energy more than fossil fuels. Innovation is taking down renewable technology costs, while fossil fuel prices are increasing as they become more scarce with the complex transition to renewable energies and technologies on the horizon. To find out more on this, keep on watching this video. Natural sources provide renewable energies, which are, as their name suggests, supplied far more quickly than they are used, but they only account for 12.6% of the energy used in the United States today. Hydropower, solar, and wind energy are all examples of renewable energy. To combat climate change, renewable energy sources are essential. They have a small or no carbon footprint and have less of an influence on the environment and human health. These non-renewable energy sources include fossil fuels. Once a plentiful supply, fossil fuels like coal, natural gas, and petroleum quickly run out as energy usage rises. They endanger our health and the environment by producing significant greenhouse gas emissions. Let's first take a look at the development of renewable energy. We've been using the natural power of the environment for ages, even though renewable energy is frequently considered as a solution for the future of our power demands. Windmills and water wheels run granaries, and the sun made the fire to provide heat and light. However, we depend on fossil fuels like coal and natural gas. Increasing global temperatures, catastrophic weather events, and the destruction of natural habitats have all been linked to the extensive use of various forms of energy. The generation of renewable and green energy has increased as a result of recent improvements in capture and storage technology and the global push toward net zero. These innovations cover a wide range of output, from small-scale installations like solar panels on a house to large-scale ones like offshore wind farms. Solar. Radiant energy from sunlight is captured and transformed into heat, electricity, or hot water to create solar energy. Solar cells used in photovoltaic systems may turn direct sunlight into power. The fact that sunlight can practically never run out is one advantage of solar energy. An infinite amount of solar energy is available with the capability to harness it, which might make fossil fuels obsolete. Utilizing solar energy instead of fossil fuels also aids in enhancing environmental and public health situations. In the short term, solar energy may eliminate energy costs and lower energy bills. Many local, state, and federal governments offer rebates or tax credits to encourage investment in solar energy. Hydroelectric. People most frequently connect hydroelectric electricity with dams, pumped storage hydropower, which uses the dam's turbines to move water, generating electricity. Instead of using a dam to force water through, run-of-water hydropower uses a channel. Hydroelectric power is flexible and may be produced by both large and small-scale projects, such as the Hoover Dam, underwater turbines, and smaller dams on minor rivers and streams. Hydroelectricity is a lot more environmentally beneficial form of energy for our environment because it produces no pollution. Ocean. Thermal and mechanical energy can both be generated by the water. Warm water surface temperatures are necessary for the numerous processes that produce energy from ocean thermal energy. The ebbs and flows of the tides, which are caused by the Earth's rotation and gravity from the moon, are used to generate energy using ocean mechanical energy. In contrast to other renewable energy sources, wave energy is predictable, and it is simple to predict how much energy will be generated. Wave energy is far more reliable than relying on variable factors like the sun and wind. The most populous cities frequently lie close to harbors and oceans, making capturing this renewable energy for the local population simpler. With an estimated capacity to produce 2,640 terawatt-hours per year, wave energy has incredible potential, but is yet mostly unexploited. Around 93,850 typical U.S. homes, or roughly twice as many as there are now, could be powered with just 1 terawatt-hour per year of energy. Biomass. Renewable energy obtained from biomass is known as bioenergy. Organic material derived from recently alive plants or other organisms is known as biomass. An example of biomass that most people are familiar with is burning wood in a fireplace. Different techniques are utilized to produce energy using biomass. This can be accomplished by burning biomass or using methane gas created when organic materials naturally decompose in ponds or even landfills. Carbon dioxide is released into the atmosphere when biomass is used to produce energy. However, plants that grow again need the same amount of carbon dioxide, which is thought to maintain a balanced atmosphere. In our daily lives, biomass can be used in a variety of ways, both personally and commercially. In the United States, biomass accounted for around 5% of all energy used in 2017. This energy comes from wood, biofuels like ethanol, and energy produced by burning municipal garbage or methane extracted from landfills. Wind. Wind farms use turbines to harness the energy of the wind flow and turn it into electricity. Wind energy is converted into a variety of processes, each of which varies. Single wind turbines are used to support pre-existing energy organizations, whereas commercial-grade wind-powered generating systems can power a variety of different companies. Technically speaking, solar energy includes wind energy. The variations in atmospheric temperature, along with the rotation of the Earth and the globe's geology, produce the phenomenon we refer to as wind. Utility-scale wind farms are another type and can be bought in contract or wholesale. Since wind energy doesn't pollute the air like other kinds of energy, it is a clean energy source. Wind energy doesn't release carbon dioxide or any other toxic byproducts like smog, acid rain, or other heat-trapping gases that can harm the environment or negatively impact human health. Due to farm turbines' ongoing servicing and maintenance requirements, investing in wind energy technology can also create new employment opportunities and opportunities for job training. Geothermal. Geothermal heat is heat trapped beneath the Earth's crust during its formation 4.5 billion years ago and is a result of radioactive decay. Sometimes, significant volumes of this heat naturally escape all at once, giving rise to well-known events like geysers and volcanic eruptions. By exploiting the steam created when heated water is pumped below the surface, which later rises to the top and can be utilized to power a turbine, this heat may be captured and used to create geothermal energy. Although geothermal energy is less prevalent than other forms of renewable energy, it offers substantial potential as an energy source. It has a relatively small environmental impact because it may be constructed underground. Geothermal energy does not run the risk of running out because it is supplied naturally. Hydrogen. As hydrogen doesn't naturally exist as a gas on its own, it must be coupled with other elements, like oxygen, to form water. Hydrogen can be utilized for fuel and energy when separated from another element. A fuel made of hydrogen can burn cleanly, reducing pollutants and improving the environment. Additionally, fuel cells, which function similarly to batteries and may be used to drive an electric motor, can be created using it. Now, the main question is, how effective is it? The resource being used determines how effective renewable energy is. Some renewable energy sources are more accessible and efficient than others, while others, like geothermal energy, have greater utility in some places than others due to accessibility. But even with these challenges, renewable energy can reduce electricity sector emissions. So what is the best type of renewable energy? Since the utilization of renewable energy mostly depends on geography, there is no optimal type. For instance, Iceland has an abundance of geothermal resources, whereas regions like Scotland's Highlands are well adapted to wind energy, while some regions are more suited to solar energy. The United States has made investments in hydroelectric power. Each sort of renewable energy has advantages and disadvantages, which are frequently supply-related. As a result, the optimum approach is frequently to combine a variety of resources. But can renewable energy replace fossil fuels? The eventual replacement of fossil fuels with renewable energy is the goal. Coal and oil are limited in supply and will eventually exhaust themselves. This implies that the energy of the future must be renewable. Additionally, as global warming persists, the environmental advantages of a clean, green, and renewable energy future are becoming clearer. Now, to fully replace fossil fuels, there will need to be innovative renewable energy solutions. Also, there is every likelihood that renewable sources will be used in conjunction with one another to provide a steady supply. There is a requirement for cleaner production methods and improved power management and storage. While a total renewable future is possible, much work must be done before the world is ready to dispense with fossil fuels completely. What are your thoughts on this? Let us know in the comments section below. And if you enjoyed today's video and found it interesting, then make sure to leave us a thumbs up and don't forget to subscribe to our channel and click on the bell icon to always be updated with the most exciting content as soon as it's uploaded. Thanks for watching. See you in another video.